Yo, Servus. So this is a very interesting, monstrous integral. I can say almost Putnam integral, which I believe that A-level people could do with just a very simple, basic things that you have learned in. Well, if you have done just half on the halfway of finishing the CIE A levels paper 2 or paper 3, then you might have actually the ability to solve this integral. Before solving this problem, I will give you some hint. It is about substitution. You have to cleverly substitute this equation. So please try to do this, and we will go back to solving this question. Okay, so I assume that some of you might get stunned and some of you might be able to solve a bit, but at the end getting infinite answer. But it's okay. I will tell you, like as I say, we can just substitute with a certain function. Well, how about we consider this substitution of u equals to ln x over x plus 1. Well, this is a very trivial thing, yeah? And we try to differentiate this, we will get x plus 1, and then using the quotient rule, and then this will be remain 1, because differentiating x plus 1 is equals to 1, and then here x plus 1 square. And then we're multiplying on both sides with x, you will get x plus 1 here, and then minus x times the ln x here, and then over x times x plus 1 square. And then remember, always include the dx on the right hand side when you differentiate u in respect to x. And hence, you can actually just use this dx here to, well, just try to manipulate it a bit. It's okay, just do it. So, well, as you can see, you have a x1 square here, which is this part. So you're able to partially cancel this denominator here, but not this one. But we will see that actually it's very important that you don't have to cancel this one, because later you will know why. So we try to get the dx in, okay? And then you will have this x plus 1 square on the top, while on this side x plus 1 minus x ln x at the bottom, and this is du. So we try to substitute this entire thing into this integral, but remember we had to set the boundaries here, which is if you observe that e, well, which is this one, you will have a 1 on the top. Well, if x equals to e, and then your ln x must be 1, and then on the denominator side must be e plus 1. And if x equals to 1, then obviously u equals to 0, because ln 1 equals to 0. So your boundary must be 1 over e plus 1, and then 0, and then the entire thing. It's okay, just it's fine, because we're not focusing on the numerator substitution, but actually the denominator substitution. When it comes to fraction, we have to just focus on, well, certain parts of a substitution. For example, this kind of, just use the numerator substitution. Oh, my apologies, I should have just get this. And then you will have here as a du. So everything in terms of du. Yeah, it comes very trivial though. It's okay, we just continue do so. And everything is good right now. Yeah, du here is a very monstrous expression here though. So actually, as you can see, we are able to cancel this expression. Why? Because if you try to, well, this expression, you try to change the expression into the left one, yeah, you can do so by actually just try to move x, just stay the x here on the left side, and then the minus x ln x on the center here, and then plus 1, and hence you get x minus x ln x plus 1, which is just similar to the numerator here. So we are actually able to cancel these two things, and hence what you get at the end is nothing but the integral from the boundary 0 to 1 over e plus 1, and then x plus 1 square over x plus 1 square plus x, and then ln square x, and then du. Well, it's very hilarious to see that because we do not have u, but you will soon see the u by dividing on each, well, on denominator and also on numerator with x times x plus 1 square. So dividing with each of them with the x times x plus 1 square, you will get the integral from 0 to the upper boundary 1 over e plus 1 is nothing but 1 over this is 1 because you divide each of them with this one. So you separate them like a partial fraction. Remember? So we cancel them, just simplify them and then get 1. And then this one, you're able to just cross out this x, leaving this ln square x and also x plus 1 square. So it's lesser. However, you need to get u. But remember, we have actually just now the u as ln x over x plus 1. So u squared equals to nothing but ln square x and then x plus 1 squared. So actually we are having from integral from 0 until 1 over e plus 1, and then which is the fraction of 1 over 1 u squared du. Wow, it's just simple. So yep, from the very complex integration, which is this one, until this one, just this simple as it seems. Well, you can just try to make the inverse using the inverse integral, well, which we're using this one. We can actually just integrate this by knowing that this is nothing but arctangent of u, and then from the boundary of this to this, and then you will have as a result arctangent of 1 over e plus 1 and QED. Anyway, I have actually a bonus question for you. So you might actually try to solve this. So you have a function which is f(x), and then you have also the function which multiplies with fx, which is called as f minus x. So the product of these two functions, they are identical because they have f, but it just x and negative x. The product of both functions equals 1. So evaluate this integral. So this might not be suitable for A-level students, but you might try to actually just make a guess if you are able to think about any function, which if you just try to substitute x and a negative x, you just multiply these both functions and then you will get 1. You can then just think about this, but I would like to teach you the new technique, which is called the king property. It's a very legendary property So theoretically, it says that if you have an integral of a definite integral from a to b of fx in respect to x, and then you will have another equivalent integral which is also having the same boundary, but you just have to modify a bit the function. You will get f of a plus b minus x in respect to x. So as you can see, it changes from x to a plus b minus x, where a and b are just the boundaries. So we gonna use this property. So we know that a equals to -1 and then b equals to 1. So a plus b minus x equals to -x. And then we can just directly substitute inside the integral that from -1 to 1, we have this integral 1 over f from -x plus 1 dx. So we have two integrals which are called integral 1 and also called integral 2. So integral 1 equals to integral 2. And so we're gonna try to use this property. We're gonna try to manipulate by adding them up. So I1 plus I2. So you will get this integral add up with this integral. Since we have the same boundaries, which are -1 and 1, so we can just add the fractions together and making it into one integral. So it's namely -1 to 1, and then 1 over fx plus 1 plus 1 over f minus x plus 1, the entire fraction in respect to dx. And then we try to solve for this fraction. And remember that I1 and I2, they are equivalent to each other. So we can just make it as a I, and then I1 plus I2 is nothing but just 2i. So 2i equals to this compound fraction thingy here, and then you will just have to make it into single fraction. So remember, they are different denominators. We just multiply it with their so-called conjugate denominator because we have -x here. So here on the denominator, the left one, you will have f -x plus 1, and then on the right hand side one, you will have fx plus 1, and at the denominator, interestingly, you will have fx times f minus x plus fx plus f minus x plus 1. And then here also dx. So recall back the property of the function, which is if the fx multiplies with its conjugate f -x, you will have 1. And so we just substitute this one with 1, and we will get 1 -1, and inside there we have the fraction 2 plus fx plus f -x, and then here you have 1 plus 1, you have 2, and then here you will have fx plus f minus x, and then the entire thing dx. So surprisingly, we have the same thing here on the denominator and on the numerator here, and we can just cancel them out naturally. So we have a 2i, recall back this is just 2i, equals to 1 minus 1, and then 1 dx. It just, you just have to integrate 1 in respect to x. So you just get x with boundaries -1 until 1, which is equivalent to 2. So I, which is the final answer that we want, equals to 2 over 2, which is equals to 1. And that's our answer. Surprisingly simple. As you can see, it's just a very random way to just guess how, and we can just consider this king property in order to solve this kind of problem with arbitrary function. So this might help you a lot in your exam, especially those who are dealing with A-levels mathematics, pure maths 3. If you have this kind of fractional thingy, it might be very useful for that you actually apply king property in solving this integral. You will be able to solve very fast, like this situation. And hopefully you have learned new things from these two integrals. And goodbye, and see you next time.